live. Boom. Going live, going live, going live. You're live.
Yay.
Hello, Internet.
Good. Hi, Internet.
Welcome to the pre-party. And put out a tweet again. Let our channel know. Feross, do you have any content statements or questions about anything? You have the doc. It's pretty it's loosey-goosey right now, so we'll let it go. But do you have anything before the show starts to say?
Not really. I mean, I'm excited for this topic. I think it'll be cool. I want to hear about what Mozilla is up to and what the state of SpiderMonkey is.
Totally.
Yeah. I think it's going to be exciting. I think it's the whole, just the idea of working on a JavaScript engine sounds pretty badass and cool. So I'm just curious to get some more visibility into that world.
It is pretty badass and cool. You're totally right.
You are correct, sir. So I had a tweet all queued up to send, and apparently my browser just doesn't have enough RAM to maintain a tab. So as I opened the tab, it just reloaded Twitter completely. So I'm going to rewrite it now. So it's going to be very brief. I'm going to say we're live, and then I'm going to put the tweet or the URL in there. That's all I was going to say. People figure out the rest.
Yeah.
So there's that. Sent out. Y'all can start your recordings if you haven't yet.
I've started mine.
Cool. I'm starting mine now.
Mine was already running.
Feross was running. And last but not least, we're going to tell Zoom to record, and it's going to tell us recording. New Zoom feature, which we're all just getting used to. Okay. For ease of use, let's do a quick clapper. This way I can just sync easier in post. I'll just say 3, 2, 1, and then on 0, we'll all clap. Ready? 3, 2, 1. Great. Please hold the applause till the end of the show. And Yulia, your last name, Startsev?
Startsev, correct.
Startsev. Okay. Feross, your last name? No, I'm not going to. You know I know how.
Aboukhadijeh.
You know I know, because it rhymes with DJ. It sounds like DJ.
Yeah.
Like you're booking a DJ. Yeah.
Yeah, you like saying my last name. I think you find opportunities.
I kind of enjoy saying it. I'm not going to lie.
Nice.
But you're kind of going the Prince/Madonna route, like online. You're Feross. No last name required. Everybody knows Feross.
Yeah.
He's that mad scientist over there that you can't figure out his last name until you book a DJ.
It's cleaner. It's just, it's just simple.
Nice it is. Simple. Plus, it's pretty unique. So, they're not namespace clashes. I got the problem of Jerod the Subway guy, who turns out is like a longtime pedophile and stuff. Terrible namespace clash. I do not want to be. I'm not associated with that man. Neither do I enjoy Subway sandwiches. So I'm doubly not with him. But is there any other Ferosses out there?
Somebody else bought Feross.com, and I regret it because I think I was like 11 or 10 years old when I wanted to buy, my first domain name, and I didn't have the like $7 to buy Feross.com back then, so I bought like the other domain I wanted for the site I was building at the time, and then a couple years later, this random other guy who spells his name the same as me bought it, and I've been on .org ever since. So sad.
Gosh.
Yeah.
Like a chump.
I know.
So I wanted Santo.com, which was like held by there's some company that just bought like every last name.com just to hold him and be a jerk and sell them to you because capitalism. But then I found out the Tuvalu, is it Tuvalu? No, that's TV. Tonga, the Tonga domain .to. So I really wanted san.to because that's a great hack. And so, but somebody owned that one as well. It's, 3-letter domain in Tonga, SAN. So I've been like hounding that for years. I'm playing the long game. I'm going to get it eventually. Every 6 months, I just go check it and see if they let it lapse. Like literally since 2008, I've been doing that. So maybe if you just stick around long enough, that guy will let it. Is he using Feross.com or not?
I mean, he's trying to have like a rap career or something. And I don't know.
We're going to give it up then.
Yeah.
Can't give that up. That's the dream. You can't give up your rap dream. Sorry, you're not gonna get it. Feross.org is cool though. It's because you're a
Good enough.
Can be an
nonprofit.
organization.
Yeah.
Yeah, exactly.
Rather than a commercial entity.
That's right. You're a nonprofit. It's even cooler.
Yeah. It gets the job done.
I think the one web domain that I wanted to get and couldn't, it's when they put up the XXX domain for pornography sites. I wanted to get yyyy.xxx,
Oh.
but someone was squatting on it already. And I was like, damn it. This
Yeah.
was back in my art school days. It was a perfect
Yeah.
artist website.
Totally. You gotta move fast on the XXX.
You gotta
out.
move fast on those. But I ended up, when I lost my GitHub access, I ended up with heg.codes. That works out pretty well.
I saw that
When
one.
they came up with the .codes domain.
Because you're code hag, so it's hag.codes.
Exactly.
Yeah, I like that domain. I'm nowhere near as creative, so I just went for JerodSanto.net. You know, I have the .com, but I redirected it to the .net because I don't know why. Back when I first signed up, I thought .net was cooler, and I've always just left it because I don't really use it anyways. Yeah. Anyways, we should do a podcast, shall we? Here comes the intro music, and then I'll introduce the show. That's the party vibe mood. I love your background, by the way.
We're bringing in the monkeys to the party.
Chandelier back there tonight. Ooh. Beautiful, like glowing. Welcome back, everyone. It's JS Party Time, and we have a great show for you today. I am joined by my good friend Feross. What's up, Feross?
Hey, Jared. How's it going?
It's going very well. Excited to have a special guest with us from the SpiderMonkey team. It's Yulia Startsev. Yulia, thanks for joining us.
My pleasure. Thank you for having me.
We are excited. So SpiderMonkey, give us the TLDR. Introduce everybody to what this is, who's behind it, what it's for, etc.
So in the beginning, there was the web. And they came up with this idea for a programming language that would be controlling the behavior of the web. Brendan Eich designed it and developed it. And it was initially called, what, OakScript? After the first name. I forgot the first name. I should have actually practiced this intro. Anyway, long story short,
so well.
There was the initial JavaScript engine before it was called JavaScript. And then they scrapped it all and rewrote it, and that's SpiderMonkey. We're almost 25 years old. We started our life as part of Netscape. And since then, we moved with the rest of the Netscape code base into being part of the Mozilla organization and making up Firefox. SpiderMonkey is a modern web browser. We are like the equivalent of V8 in Chrome or of JSC in Safari. And it's developed by Mozilla. We have contributors from the outside as well. And we're also embedded in a number of other domains. For example, inside of GNOME, a couple of databases that you might be familiar with, and other places like that. That's SpiderMonkey. And we really like heavy metal. So these posters.
Yes, they have all sorts of cool posters, which they put on their website. We'll link those up in the show notes as well. So how did you get involved?
So I have a bit of a weird backstory for ending up as a compiler engineer. I'm completely self-taught. I started learning how to program maybe 5-6 years ago now, maybe more. I've lost track of time. It's all a blur. But at some point I was like, I began programming, and I was like, okay, this is just a job. I'm just doing this to like get my next paycheck. And then I started getting really interested in, how do you program? What's the best way to do it? What are all the tools, all these things, all these interesting bits and pieces that you can work with? And eventually I got involved with developer tools and got onto the DevTools team in Firefox. That code base is entirely done in JavaScript and HTML. So if you wanted as a JavaScript developer to go and like do your first contribution to a browser, because browser, it feels like this significant piece of software, that's a really great entry point, the DevTools. I think several of the DevTools teams actually use JavaScript as a backing language for what they do. So I started working there, and I got even more interested, like what's the design of the language? How do compilers work? How do you make this magical tool that is a programming language, which is so expressive and you can talk to other people through it? How does that happen? So I started teaching myself a little bit about compilers, a little bit about how languages are designed. Somehow by magic, I ended up on TC39 and helping with the design of the language, asking questions, helping along from the developer tools perspective, like what does this new language feature look like in terms of developer tools? And eventually I moved entirely onto the SpiderMonkey team, which was my first exposure to C++, and also my first full-blown exposure to the complete structure of a compiler and working on it directly. That's the short version of the story.
Wow, that's such an intense career arc. You started like programming 5 to 6 years ago, and then you find yourself on TC39 and writing compilers. That's quite the journey. Must be intensely, like, I don't know, there must be something like different about how you learn, or you must be like intensely curious to keep digging, to the next layer below the stack at each stage of that process. You didn't just settle at the sort of the level of understanding that you had. You kind of kept going. That's pretty cool.
Yeah, I think it's I think one thing, I don't know, it might be so something someone once told me is that I was very brave, but my feeling of the situation, my comprehension of the situation was, oh no, I just didn't know what was next. Yeah. So somewhere between ignorance and bravery. Yeah. So you end up in this situation. But yeah, generally like curiosity. And also I think one thing that helped me go from not really knowing that much about programming to working on a compiler was I actually never accepted that I couldn't. So some stuff was really, really hard. And I was like, I don't really feel all that smart when I look at this, but I never thought that I couldn't. I mean, it's something that I've been telling others when they struggle, like, if you stop yourself without allowing yourself to fail, and then succeed, then you're not going to actually make it to that goal that you're going for. I have a lot of failures.
Yeah. Well, one thing I truly believe is that perseverance is one of the best character traits of great software developers, and like the ability to persevere through that trouble, which you apparently have, because a lot of us bang our head against, hard objects, and then eventually our head hurts and we're like, I'm just going to stop banging it. But it seems like you really just power through until you get over that hump.
Yeah.
You also, Meteoric Rise, you also, I think, have a new record on JS Party, time to first shout out. So in our chat, Omri gave you a shout out. Thanks, Yulia, for your work. I use Firefox every day to make sure that Google's V8 monopoly does not go unchecked. So there you go.
I mean, diversity of browsers is very important to keeping the web healthy and making sure that everybody has a voice in the ecosystem as much as possible. So thank you so much for using Firefox. It's always great to hear.
Tell us what your work looks like then, because you magically on TC39. We're going to talk about some of the new things going on, the advancements of the SpiderMonkey team, and all that you all have been up to. But I always get curious, like, I always ask open source developers, like, what does your day look like? Because it's kind of in their own hands. Of course, a SpiderMonkey team member, I don't know what you do all day. What is it?
Right. So I have an interesting role on SpiderMonkey because I also handle our engagement with the committee. So part of my time, it can be an entire week, is dedicated to proposal reviews, so reading spec text. It's dedicated to opening issues on repositories about issues that have been found either by myself or other engineers on the SpiderMonkey team. If they haven't had time to sort of formulate the issue into an understandable form, then I will go and do that. Or it's also talking to other SpiderMonkey engineers and asking, what do you think about this proposal? Have you taken a look at it? Any concerns? If they've been working on it, I try to surface anything that they're unsure about to make sure that we communicate well with the community. So that's one part of my work. Another part of my work is implementation. At the moment, my focus is not entirely in SpiderMonkey. I'm working on Gecko. Gecko is our DOM engine. So that's the embedder in the case of Firefox of the SpiderMonkey engine. So it takes care of like script loading, and that's specifically what I'm looking at. How do we load scripts and then execute scripts in the browser? And at the moment, the specific task I'm working on is looking at how we're loading modules, so JS modules, into workers. It's a feature we don't currently support. It was recently, support was added to it recently by JSC, and V8 has had it for a little while. So my day starts basically with turning on my build machine and staring at a blank screen for a bit while I gather up the courage to open up a 2,000-line file and then start poking away and taking a look at what I can do that's reasonable, asking questions about, do I understand what's happening here? A lot of it is reading code. And of course, coding. And that makes up a big chunk of my day switching over in the latter half of the week, often to meetings. So a lot of coordination meetings that I mentioned earlier, assuming that they don't make up the whole week, and stuff like that. That's generally what it looks like.
Staring at code all day. That's like living the dream right there, you know?
Yeah,
Keep those
right?
meetings away. Keep them away. You
Yeah.
also find time to live stream on Twitch a few of the things you're doing. You want to tell folks about your live stream and the kind of stuff that is on there?
Yeah. So there's an interesting thing that's happening. So the live stream is on pause right now. But what the live stream was is on a bi-weekly and then monthly cadence. I had to slow it down a bit because of the attention that it took. What I would do is I would give a guided tour through how a specific complex feature was implemented in Firefox. I started off with what I thought was a small bug, and I took people through everything. So you start at the spec text, reading the spec text. How do you read spec text? It's a weird language that we use there. Where we've got like proper grammar. I don't know if all of the viewers are familiar with what a language grammar is, but it's a way of writing out how a programming language's syntax is supposed to look. We call it a grammar. And then also, how do you read the semantics? So we walk through all of that, and then we go through, and in Firefox, we would implement it, test it, and then ship it. Right now, what the series is looking at is top level await. It's a proposal I was involved in specifying. We just took it to stage 4. Top level await allows you to use await on the top level of a module scope, so without any function wrapping it. And we're implementing that from scratch as a guided tour and reading all of the spec text associated with it. What's interesting about that proposal is you can see how much the specification diverges from an actual implementation and the kind of things that an implementation has to deal with, like performance, and how we solve those things. So that's what that is. And it's on pause right now. It's going to come back probably in August or September. The reason it's on pause is I did do this meteoric rise in CS, but of course it didn't really stop there. And I'm in university now. I just started my master's. So I've taken a bit of time off to acclimatize to doing both schooling and work. So that's why it's on pause, but it'll be back soon. And I'm really excited to show people how everything works, especially with my new knowledge of real computer science.
Mm-hmm.
Wow, that's super cool. I highly recommend people go back and get their masters like in the middle of their careers. I did the same thing and it was super fun. I think you're going to have a really good time.
Yeah, I totally agree. Like doing a master's when you've already found what you enjoy doing. Like for me, compilers are just so cool. Languages are so cool. All of this stuff is amazing. So now I'm doing my master's specifically on that. And I'm like, right now I'm in a software analysis class and I'm learning this stuff that I didn't know the words for, and I can directly apply it to what I'm working with. And like all of the things are connecting. And I feel like I have a much deeper understanding that I would have otherwise. It feels much more applied. So it's really cool.
Yeah. When you learn certain things as an undergraduate, it's just so much schooling has already, you're like getting, 4 years of schooling without any real chance to meaningfully use what you're learning. And so at some point you just, I don't know, at least I feel like you kind of get filled up with knowledge, and it's actually beneficial to go out and use it, try to use, use the knowledge. And then what happens is you run into situations where you hit the limit of your understanding. And at least for me, I was like, I don't have time to learn this thing right now, this big topic, but one day I'll sit down and I'll learn how this works, and it'll make my life easier next time I run into this situation. And then when you go, when that happens for like the third or fourth time, and then you go back to your master's, and you're finally exposed to that topic. You're like, oh my gosh, this is really important. Like I've run into this before. Now it's my chance to finally learn it. And you're like super eager about learning it, and that it's going to be really important, and then you remember it. It's just so much more like meaningful when you know that it's a thing that is actually important because you ran into it so many times before, Yeah.
It's really cool.
Sorry, go ahead.
I don't know, I was just going to say, it's really cool because everything connects right now. I'm going through some concepts that had I not known how a compiler works and worked on one and been like, oh God, this is my day job, then like coming to those mathematical concepts and being like, what is this? I would have had so much more trouble, and I would have just sort of, figured it out for the test and then forgotten about it. But now it's like, no, this is my life. It's really cool.
Yeah.
I was just going to add that there's also a burnout of schooling, right? So I'm just thinking about my path, and I could see this path that you guys are on being something that like would be attractive to me now. Whereas when I just graduated, I had just finished like 16 straight years of schooling or whatever it was, right? Elementary up through university. And I was just not going to be, I was just done. I'm like, I'm not going to go to school for my master's. I've just had enough schooling. And I feel like a lot of people, when they continue that path, they're just not sure what to do next, and they like to learn more than I did. I didn't really enjoy it all that much, but now that I've like had the gap and I've had, I guess, 15 years in industry, I could see where I have specific things that I enjoy and I could dive into, like you found, Yulia, with compilers. And I appreciate learning for learning's sake way more than I did back when I was in school, because I had to learn because that's what people told me to do for 16 years, right? I could see that being like refreshing change of pace, as opposed to just going like one thing after the other all the way through. I always looked at people that, went from straight through grammar school up through their doctorate, like 20 years of schooling. I'm just like, I just couldn't relate to that, but I can relate to this sentiment. So I think that's an interesting thing.
I think in general, schooling should be more of a lifelong thing, and we shouldn't compactify all of it to like the front of your life and then just stop at some point, and then you never step foot on a university campus again. I think it should be more of like, I wish it was like you could take a class, one class every semester, or like one class every year. You just drop into something, to kind of enhance your knowledge throughout your career. Yeah. But it's not easily structured that way. It's like, even when you want to go back to get your master's, you kind of have to like put your job on hold and then like, or take some time off to do it.
Yulia's over there
so,
like, I'm not putting my job on hold.
You know what I mean? Though? You know what I mean? It just takes a lot of time. It's like you have to basically do it in a conconcentrated.
You have to put your live stream on hold.
It is hard. Like, so I'm doing a remote program that's famous for being the equivalent of its on-campus program. And it is hard. It is really hard to do. I have definitely, I haven't crammed in 10 years, and now I'm cramming again, and it's really intense. And I'm only doing one class. So this thing that you mentioned, dropping in for one semester, and I'm thinking like, if I had to do this for my entire life, I think this would be very difficult.
Oh, wow. Okay.
So I'm doing exactly that right now. But I do think that, so I've been thinking a lot about education because of course I'm interested as an educator. The reason that compiler exists is because I think that compilers and computer science should be accessible to everyone. I think that this shouldn't be a scary piece of software to write. It should be something that it's like, oh yeah, I understand how that works, and I understand like the basic structure of it and how it's built and what it means, and I could do it, rather than, oh, I'm someone who only knows how to write JavaScript applications and this world is blocked off for me. Part of the reason why I kept digging was because I felt like that. I was like, oh, I don't know how compilers work. Like, I need to really work if I want to learn how the compiler works. And it's true, you do have to really work to learn how that thing works, but it's accessible. And I think how we do education determines whether or not people think that they can take on these complex topics. One thing that was really inspiring for me was watching Dan Abramov's series on React. And he made a number of topics that could have been explained in a very complex manner, very approachable to someone who was rather new to programming. So that was early on in my career as a computer programmer. I think that's very important. And I have a lot of comments about university style education, like exams. Oh my God, why do they exist? I kind of understand it, but at the same time, as someone who's studying for the sake of studying and not for the sake of accreditation, I feel like exams are sort of this arbitrary bar that's put in place, quizzes, exams, and all this kind of stuff that I don't actually learn all that much from, and they mostly cause stress. And I feel like I learn a lot more from like digging into a book and like doing the exercises and then talking to people and making sure that my ideas about a problem are correct rather than sitting down and like having a test. So I don't like tests.
Going back to school at this stage in your career really it highlights all the things about school that are, that are just weird that you don't realize when you're in it the first time. Right. Yeah, exams are one of those for sure. And I think they're pretty helpful for people who would otherwise not do the work. It's sort of like like when you have a deadline coming up and you finally do the thing that you've been procrastinating on, like I think that's the purpose it mainly serves for people. And then, I mean, there's the whole like evaluation aspect of it, but I question whether that's actually what the university is after with it, because anyway, yeah, it's just interesting. It's definitely interesting perspective to go back. It's cool.
Yeah. Well, we might get stuck talking about school this whole podcast. So
yeah, we can move on.
Let me ask one question that's somewhat on topic but off topic, which is, you found that you're fascinated and excited about compilers, and I'm wondering if you've thought about that analytically, like why? Because people get excited about different things, and like somebody really loves baseball, and you're like, if you ask them why do you love baseball, maybe they thought about it, maybe they haven't, but they can probably outline have you thought about that? What is it about compilers that really gets you going?
That's a great question. So actually, there's two things that I'm really fascinated. Well, three things, which I consider to be some of the most important parts of a process that I would call language design. So language design, you might think of it as the process of figuring out the formal specification of a language and how it works, and what are the proofs behind it that a language is correct and does the right thing, and that it's sound. For example, with type systems and whatnot. But there are like lots of different parts to language design. So soundness is one part of it. Then there is, there's the formal aspects, the observational aspects, like how does the language perform? Is it fast for certain tasks? Is it good for concurrency? Then there's another part to it, which is how does the programming language impact the people who write programs with that programming language? And how can a representation of a programming language impact how people solve problems? Really interesting example of that is the programming language R, which a statistician can pick up in about an hour and become productive in. Another excellent example of an interesting programming language that impacts how people model problems is Excel. JavaScript is another interesting programming language that models how beginners enter into the field of programming and then start immediately doing something that works. And then there's a final aspect to it, which is how do we collectively design languages? How do we determine what the problems a language is trying to solve are and come to an agreement about that? So that's the collective, that's the committee work. So those are the pieces that I'm interested in. And actually working on a compiler allows me to stretch that whole area of language design that I just mentioned to you. So I get to go all the way from the nitty gritty stuff about like, how is it performing? How is it built? Is it right? Is it what we want it to do? Does the syntax actually work from a formal perspective, or not the syntax, are the semantics correct? And then we can look at syntax and be like, okay, for programmers, how are they reading this code, and are they coming to the right models in their minds about what it's supposed to do? I find that really, really interesting. And then finally, we get into this, how do we make decisions as a group? And I find that when I say that I'm a compiler engineer, I actually see it as encompassing this whole realm and not just the technical aspects of the work. And it's a really cool place to work.
Great answer. Break there? We'll break right there. Okay. We're in a break. This is a break. Feel free to take a break.
Sorry. Like, what am I talking about?
No, it's good. That's a good answer. Since we're on a break, and since Chris wanted to be here and couldn't be here because of his illness, I wanted to bring in the spirit of Chris Hiller into the show via this clip that I got from a recent episode.
JavaScript should be destroyed.
There we go. So there's Chris for you.
What was the context of that?
He was being sarcastic, but it had to do with I don't remember. I don't remember what the context was.
It doesn't matter.
It was in the show, the last Node show about running Node in the browser, and I don't remember. I just remember thinking that's a really funny thing to say. I know he laughed at, like, I know it wasn't serious, but I'm like, that sounds like something Chris would say.
JavaScript should be destroyed.
And then the other thing he says all the time is,
what?
What? Love you, Chris. It was great. Last episode, our guest, I think it was Eric, answered a question. Like, Chris asked a specific question. It was a technical question, and then Eric answered it. And Chris just kind of stared at him, in the Zoom, and no one talked. And I said, Chris, are you tracking that? And he goes, nope. Sometimes people just feel compelled because of social awkwardness to like just say, yeah, I know what you're saying, but not actually get their question answered. He just goes, no, I didn't. And so then Eric actually took a second stab at it and explained it in a way that I think connected. So it was good. I just love Chris for those reasons. Yeah, I've been collecting clips. Here's Emma.
You did not just say that.
And here's Amel.
Web lovers.
So I'm getting together a soundboard.
The JS Party soundboard.
The JS Party soundboard. That's right. That's
Do you have anything for me yet?
Far. No, I haven't. You have to say something ridiculous so I can clip it.
All right.
Okay, so that's the goal of this stream, this podcast. Feross is going to say something absurd.
That's right.
And you're going to have it for your soundboard.
Yes. He's going to get on the soundboard today. That's your job. It's going to be tough.
Don't think about it now.
Not as hard as the time that we worked in all of the lyrics to The Wind Beneath My Wings into a conversation about Tailwind. That was tough.
Did you?
We did.
Yeah. We just
Holy cow.
We found random opportunities to mention a line of the song, and then at the end, after we did it, then Jerod stitched it together and then played it at the beginning of the episode. So you just get like all of us saying, and he put the music behind it and everything. Yeah. And then when you listen to the episode, you can like identify where we threw in the lines.
Yeah, we throw in a little ding every time we say one. It all started because I put in like placeholder titles sometimes, and I just put in Tailwind Beneath My Wings as a placeholder title. And then K-Ball was like, you guys should work the lyrics in. And I was not going to do it. But then Nick was all about it. And so Nick started doing it. It was funny because we were doing it unbeknownst to anybody else. So Feross didn't know. Adam Wathen, who was the guest, didn't know. And Nick and I knew. And for me, I didn't have the gusto. I just couldn't do it because Nick was just saying things that they just don't make any sense. And I'm like, we have to tell them because this is so awkward. So we told Feross and Adam during the first break, and then they got in on it throughout the rest of the show, and it made for what was my favorite episode of last year for sure.
That's
so high recommend.
That is quite an achievement, I have to say. That's amazing.
We felt like we really merged art and podcasting, and probably copyright infringement on that episode. So if Bette Midler is out there, we're sorry.
I would say that we definitely enhanced it enough to qualify as fair use.
Yeah, I would think it's fair use.
Yeah, we definitely added enough unique contribution.
We leveled it up quite a bit.
Yeah.
Or down, depending on if you like quality music. All right, that's the break. Unless anybody needs to step away, we have time. No rush. I'm good. I thought we'd go into kind of like what's new and shaken in SpiderMonkey. I would love to hear about the TC39 process. Maybe we can use top level await as kind of the linchpin for that conversation since it's been through it recently.
Yep.
Cool. Sound good for us?
Mm-hmm.
Okay. Lost my notepad. Give me a sec. There it is. So one thing that you and the SpiderMonkey team works on is developing features not in a silo, but alongside other people who are developing the same features, and then debating how those features could look, and then approving which ones are good, which ones are not good, which ones need to be changed. Are we implementing? Are we not implementing? When? All of these things, like you said, a lot of it is the communication and the humanity side, which is a fun challenge, I believe. So you've had a lot of interaction with TC39. As your work with SpiderMonkey, and including recently top level await's a thing that's been, I guess, approved or ratified. I don't know the language, and is going into the browsers. And so that's like a big feature that a lot of people have been waiting for and are excited about. Maybe tell us the top level await a story, and we'll use that as kind of a view into how TC39 works.
Okay. I don't know if I remember all of the details of how top level await evolved, but I can try to take you through sort of our pet feature. We can call it foo, or we can take top level await as that example and just walk through the journey of someone's got an idea and then it turns into a full-blown feature. Okay. So let's say anybody, like for example, Feross or Jerod, either one of you could come up with an idea, just any idea, and say, it would be really great if this was in JavaScript. What you would do then is you would go to our discourse, the TC39 discourse. It's discourse.tc39.es, I think. I need to double check. If I'm wrong, go to the TC39 website, which is tc39.es, and then take a look at how to get involved or the community side. And the discourse is listed there. It's also in the footer. We have an area in the discourse for posting your great new idea and getting feedback from delegates about whether or not that should be included in the language, or what they think about it, or where we've tried something like that before and it failed, or where they see inherent flaws in it, or it might just be picked up. What we call this idea of yours, we have a name for it, is called stage 0, or the straw person proposal. And it can be really anything. Now, to get it to stage 1, we have a 4-stage process. Stage 0 is just any idea on the internet. Usually we know about it. Sometimes we don't, like things are floating around. You can create a example repository of your idea using the TC39 proposal template on GitHub. You just create a repository, a repo based off of that template. And there you go. You've got your first stage 0 proposal. You've discussed it with people on Discourse. And ideally, someone on Discourse who is a TC39 delegate has come along and said, that's a great idea. I want to take that to committee. And you get to be a part of that whole process from that point on. So in that case, you take the role of the author, and the TC39 delegate who's adopted your proposal will be your champion, the champion for your idea within the context of committee. That idea is taken to committee and presented for stage 1. So it goes onto the agenda. We meet, right now we meet 8 times a year, and we discuss it in something called plenary for about half an hour to an hour. And people will say, oh, this is a terrible idea, we should never do it. Usually nobody says that for a stage 1 proposal. We try to bring ideas in. It's our siphon for like, what's the internet thinking about? And in general, we consider proposals entering stage 1 as problem statements. So if we take, for example, top level await, and you read the top level await proposal repo, we have this section there called the motivation. And the motivation is stating the problem that top level await is trying to solve. Stage 1 is really like, what is this thing? What's wrong? And later, how do we solve it? So the solution and the problem are bundled together. And I think we still, like, this is still something we're figuring out, like, how do we separate those two so we can really discuss the problems in isolation and understand them fully before we go forward with the solution? Right now, they're sort of like tightly coupled. So if we read the motivation section of top level await, the motivation there is that the syntax overhead for doing something that will allow you to pause at the top level of a module is really, really painful. Syntactically, it's buggy, and like people have tried all different ways to get around this, but it's just not great. So that's the motivation for top level await. And I think between stage 1 and stage 2, so stage 1 is we've accepted the problem, go ahead and investigate it, and come up with the best solution that you can given the information that you have. So figure out what the spec should kind of look like, figure out what kind of initial problem areas exist, figure out what the solution should look like. And that's how we ended up with top level await having just the await keyword before whatever you're awaiting. There were other solutions for top level await. One of them was to say that the module, you mark the module that you're importing as async. That's another way to do it. So rather than having, right now it's implicit that something is asynchronous, but we had an idea of it being implicit. And there are still ideas around this floating around in committee that we've been discussing recently. So now you want to take your proposal, whatever it is, to stage 2. By stage 2, you should have a complete idea of what the API should look like for that proposal. You should have a good argument about how it solves the problem that you want to solve. And you should already have a spec text ready. Stage 2 is about ironing out the problems, ensuring that we haven't missed anything. So this is sort of like the draft process. We're drafting the final spec text. We're figuring out everything that we can before we start implementing the proposal fully in browsers. So that may also come with a polyfill. Maybe one browser or another browser, when they think that the idea is really good, they might implement it early at stage 2 or not. So that's what the draft stage is for. And then we move into stage 3, which is where I usually get deeply involved. Like, for example, the transition from stage 2 to stage 3 is very hard. We want to make sure that we don't miss anything that could potentially be a problem going into stage 3 that we can foresee before we have to implement the work. Because when we're talking about implementing a proposal, for example, top-level await took 6 months to implement. Most browsers were around the area of 6 months of engineering time to implement it into a given browser. And these things can even be more work, like they can be a year of work, multiple engineers working on it. So we have to be really careful before we invest that kind of work, that we're not giving a specification that's inherently buggy. Although, you know, sometimes you miss things and we have to roll back. So the stages don't just move in a forward direction, they sometimes loop back. So for example, one example is we just had regular expression group indices move forward to stage 4. That was stuck at stage 3 for a long time. It didn't actually get rolled back. We had, it's details, like we've had stuff rolled back when we've had inherent problems between proposals that we didn't foresee. So we had these 2 proposals in stage 3 and one of them had to be rolled back because it turned out that that was the one that needed to be fixed in order for it to move back up the stages to stage 3. So something like that can happen. Or we may end up re-questioning whether or not the grounds for the proposal were appropriate and then moving it back up. Another important detail is that committee, there's disagreements about this, but committee doesn't really reject proposals. So let's say something is going through the stages and you're like, oh God, this should never go into JavaScript, and you're really worried about it. One thing to pay attention to is if the proposal has been blocked and hasn't been progressing. We don't generally formally reject ideas. We keep a record of everything that we've tried so that, you know, next time, like maybe someone comes along in 10 years and is like, hey, that thing that you thought was a bad idea, actually, we have a really important use case for that now. And then we can pick up work from that proposal and use it as a historical base for future work.
That's cool.
So yeah, it's a very long, complicated process. I'll try to keep it shorter. And then finally, stage 4 is spec. We're in spec. So that's where top-level await just made that jump. We went from stage 3 to stage 4 last meeting.
I have questions, but Feross, if you have anything, go ahead.
No, I don't have any questions.
Okay. I got a couple teed up. So what do you do in the case of competing ideas around implementation or API? So you mentioned the implicit await versus the explicit, and there was were those 2 different proposals, or was there one proposal and then people debating how to go about that proposal? And then how does a decision come out? Is there a vote? How does that work?
So we do both things, actually. We debate within the context of a single proposal, and sometimes we also have forks of the proposal, which show competing ideas about how this thing could be implemented. Now, the most famous fork, we call it the back pocket solution. The most famous fork of a proposal was ES5. So perhaps you recall ES4, this specification that we worked on for 10 years. And you go from ES3 directly to ES5. Why did that happen? Because ES4 was developed over 10 years, and then implementers took a look at that and said, this isn't implementable. We can't do it. It's too much. It had doubled the size of the specification. We couldn't implement it. So what happened is a group of delegates sort of sprung off and sort of like started taking pieces of this massive specification, and we're like, okay, these pieces make sense as a incremental improvement that is scoped and can be implemented. And that was, I think it was ES3 point something. It was this bridge, ES 3.5, something like this. It was this bridge specification before we made the jump to 5, and we completely skipped ES4. So that's the most famous example of a back pocket proposal. We had also back pocket proposals come up for private fields, which was rather contentious. But what's interesting is those back pocket proposals were always like, oh, there's this specific problem with our current solution to the private fields problem. We propose that we do it this way instead. But every time that we got into debate, we would compare the 2 and discuss whether or not this second idea was a valid, better solution than the initial idea. And we always came back that initial idea was the better one. So we went through this process of deciding like which one really fully covers the problem space. And that's how we ended up going with private fields the way that it was designed. We also have people in committee who are protecting things that are intrinsic features of the language that could potentially disappear if we didn't protect them. One famous example is polyfillable implementations. Can we polyfill this thing? For example, had we specified modules a little bit differently, then you wouldn't be able to inject code so that it would run before the module ran. Polyfilling, like let's say a browser had the wrong implementation of promise, you wouldn't be able to fix that implementation of promise, because if we designed the module system in a specific way, then the modules would run before you're polyfilled it. So that's one example of sort of a critical idea to the JavaScript language that needs to be possible, that we try to maintain. And these kind of features of the language, they're a little bit strange. They're not all written down. So some of our decisions might look a little bit like, why did you decide to do that in that way? Oftentimes it's because we're protecting certain features of the language so that they're still possible, so certain applications remain possible as we evolve the language.
That's interesting. So you should have some sort of I would think there would be a list, you know, like the 10 commandments of JavaScript features, like thou shalt be polyfillable. It sounds like a pretty good guiding principle of like, hey, if your proposal is not polyfillable, well, it's not going to get accepted. Does that not exist anywhere? Is that just in the psyches of the committee, or what?
At the moment, it's sort of held near and dear to different delegates. Like different delegates maintain certain values about the language that they protect. So there's a real risk, and this is why the question of how do we design as a group is so important. This is why this is the fourth tier of language design in my mind, is because we need to be able to make these decisions effectively, considering all of the values that are represented by this cross section of people. And it's also a little bit arbitrary, right? Because we have specific people on the committee. We don't have the entire planet on the committee. We wouldn't be able to handle that amount of information. But the people who are on the committee do care a lot, and they're largely volunteers. And they have been with the language for a long time. To mediate for this, it's the bus problem. Like if one of us gets hit by a bus, then like we won't necessarily pay attention to everything about the language. To mediate that, we've started a new project, which is writing down the intrinsics and making them a part of the normative text and specification. What does normative mean? Normative means that it impacts the implementations, and it's a much stronger guarantee than another part of the specification, which we call prose, which is explanatory text around the specification that does not impact the implementations. So that's one mediation that we have upcoming that should eventually come into fruition, and we will have a list of things that we think about when we design the language.
So how big is the committee?
It is, well, I don't know exactly how many members. So members are companies. I don't know exactly how many members we are, because the members belong to ECMA, which is the standards body that we're a part of, ECMA International. And at committee, we usually have between 40 and 80 people present.
And in the case of a contentious proposal, does it just end up going to a vote, or how do you resolve conflict?
We have to all agree. So this is an unusual thing. It's a unanimous agreement. This is it's a unanimous agreement not to block. So not everyone is necessarily happy with the proposal, but they all accept it in the current form that it goes forward in. So that's 80 people have to say that they won't say no.
That sets itself up for a filibuster, doesn't it? You got one stuck member that just like, that's a lot of power in the hands of one member. No, I'm gonna block.
Yeah. It's a lot of power in one member.
That person just has to be, that entity just has to be convinced. Is that how it works?
Yes. And usually, excellent question. It works this way because the committee used to be smaller. It was like 12 people. And at the time, this is when ES5 and ES6 were being developed. At the time, it was a system that made sense. But as you probably know from other political systems, once you have such a system, it's very difficult to move away from it. That said, it has saved our skin a couple of times. One example is observables. This was a popular feature proposal. A lot of JavaScript developers liked it a lot. And there was one person who said no. And they said no after, the other thing is like committee work isn't free. Like we spend a lot of our lives thinking about these programming language features and how are we going to implement them and how should they be spec'd. So it's a lot of work that you're saying no to. There's a lot of social pressure to not say no. And one person said no. and they completely stopped further discussion on that proposal. They said, no, this is, and then one thing that we're encouraging now, if you read the proposal document today, we have an important document around how we make decisions. It's called the proposal document. It tells you how to block in an effective and productive way, because just saying no isn't very good because it doesn't lead us anywhere. I think one important aspect of that document is that it says when you say no, you have to give a reason so that we can learn from why a proposal failed. So going back to the story about observables, one person said no, everybody was mad for a while. And then like 3 years later, people were like, oh, thank God we didn't do observables. That guy was totally right. We should not have done it for exactly the reason that he said. So it's an interesting process. I think one of the big reasons why it's working for us is that we have a lot of people participating in good faith. People want JavaScript to succeed. They want it to be a good language. They aren't blocking just to be difficult.
Mm-hmm. I would imagine there could be situations where you have members that are not acting in good faith, or maybe not just not in good faith, but in their own interests. So like if you have members who represent Apple and you have members that represent Google, those two entities could be at odds. And so maybe they have corporate reasons for certain features working certain ways, or doing this and not doing that. Ultimately, they have to implement it into their browsers anyways, so they could also, I guess, hold out on that aspect. But to me, it's just fascinating, and I appreciate all the work that y'all do, because us regular JavaScript developer, like, I never think about this stuff. I never thought how much, for lack of a better word, political machinations go into deciding like how I wrap my regex, right? Or how I import a module. Like there's a lot of thought and debate and politicking in the sense of like dialogue that goes into these things. Feross, do you ever think about this? I guess every once in a while when we have someone on the show, I think about it, but not very often.
Mm-hmm. Yeah, I think about it sometimes, but most of the time I'm I don't have as much time as I'd like to devote to looking into this stuff. So I just kind of learn about things when someone writes a nice blog post about them that explains how they work.
Exactly.
And sometimes I get involved earlier when there's like something that the language just feels like it's missing, and then I'm looking for some solution. But this usually happens more with like web features, so it's kind of outside of the realm of ECMA, but it'd be more like I'll find just some browser proposal that I'll get involved earlier with that kind of stuff. Less so in the JS language itself.
Language.
Yeah.
Yeah, I think it's also very interesting is how different HTML standard is compared to ECMA in terms of its governance. And you'll also find like different standards bodies have a very different governance structure, and you end up having different conversations as a result. That's very interesting to me. And thinking about like how do we best come to those decisions is just a very interesting area. I want to pick up,
I just think a study of those, like a meta study of here are N organizations that do standards in technology space, and based on these criteria, actually this way of going about it is better than that way for these reasons. Like, so you could, when it comes time for you to pick your governance model for your foundation or whatever it is for your specification, you can say, actually, the way these people are doing it for these, scientific criteria that I can't make up off the top of my head, this is a good way of going about it. Or maybe the 100% unanimous thing is like, makes total sense in practice, or its pros are more than its cons, and so that'd be a good one to adopt. Or maybe it's actually slowing y'all down and HTML folks do it better, and that would be a smarter way of doing it. I think maybe those things exist, and this is just a world that I don't live in, but that would be cool.
Go ahead.
No, you go ahead.
I was just going to say, it's really interesting that you bring that up, because there is a study of how people make decisions, and it's called argumentation theory. It's basically the study of how rhetoric really works in large-scale discussions. And when I started looking at this, I was like, oh, okay, cool, rationale design. So like lots of languages have rationales. How are they designed? But then also discovering programs that can determine the rationale for how a certain decision was reached. Those also exist. And then there's people studying this and writing philosophical texts about how decisions are made, what kinds of arguments have weight, which ones influence the discussion but maybe aren't correct, is another really, really interesting study. And in fact, part of what I want to do as my master's work. So
Cool.
we have a professor who specializes in that, and I've been in touch with him a little bit. I'm hoping to convince him to take me on.
You have to use your argumentation theory in order to convince him.
Mm.
What were you going to say, Feross?
I forget now, but actually one thing I'm curious about that just came to mind is how would you say that your perspective differs from some of the other members? I don't know if you represent, just sort of, I'm guessing you also represent, SpiderMonkey or Mozilla's position for, for the other people. You're bringing the sort of opinion of the organization to the group. But yeah, so how would you say that like your or Mozilla's perspective differs, and like what sorts of proposals do you find yourself sort of frequently at odds with or more in favor of?
It's a fantastic question. So that actually brings us back to something that Jerod said earlier about, let's say you've got Google and Apple arguing over something. One thing that happens pretty often is you have the browser space sort of saying like, this is an important feature for us. And then other consumers, other embedders of JavaScript being like, well, actually, we have other concerns. We had a really interesting discussion recently. So there's two discussions I'll bring up. The first one is around realms. I don't know if you've heard of the proposal. So probably everyone's worked with iframes, and you know that you can pass information from the parent document into the iframe. You can actually pass objects directly in between those two documents. What realms are is realms give you the ability to create a global, a separate JavaScript global, without creating a document to embed it in. So it's what you can do with the JavaScript in an iframe without having the iframe wrapping it. Yeah. And one thing that was important from the browser's perspective is that you couldn't arbitrarily pass objects between these two things. This was something that was viewed as a mistake in the world of iframes. Now, for other environments such as Node, this was like, well, no, this is something that we do want to do. This is a really nice way to program. We want to be able to pass objects unwrapped. So that was one place where we said, no, we can't do it like that. Additionally, we also said that the JavaScript space, what we specify in ECMA, shouldn't be kept separate from the HTML APIs that are provided into JavaScript. So for example, fetch, or maybe something like B2A or A2B APIs that, I forget, one of them's in JavaScript, one of them's in HTML, and you, as a JavaScript developer, you shouldn't need to know which standards body specified something in order to be able to use it. So one requirement we had for Realms as well was that we consider a few HTML APIs that should also be wrapped in the Realms proposal. So that's one example where we took a strong position, and that shows also the browser interest. This is a common thing that we take, like we say that JavaScript should still be coherent with the web. And that influences things for places that are not involving themselves in the web, like embedded JavaScript running on tiny microchips. They don't care about that stuff, but we do. So.
That makes sense. Yeah, of course. Yeah. I mean, as a web browser implementer, you're going to have opinions on that. Yeah. Yeah. Realms is a really cool proposal. I'm really looking forward to that. I kind of want to build some stuff with it. It's really cool. When's that, by the way, when is that going to be? When do you think that's going to be something that we can play with?
Get an ETA on our favorite features.
Yeah,
well,
exactly.
I think you may be able to play with it already. Like you can work with the SES polyfill that allows you to do some of the stuff that Realms promises to be able to do. Or if you want, you can like grab the Firefox browser and try playing around with the compartments that we have, which is essentially the Realms proposal, because we do have something that allows us to generate JavaScript globals without having a document, but it's all internal browser APIs. Like we're really happy to expose that. And actually, the direction that the Realms proposal has taken now, isolated Realms, is something we're very happy with, because it not only maintains the restrictions that we represented as browsers, it also follows some of the design principles that HTML has, which is that APIs like this should be async. So we're really happy with that new proposal, and we're really hoping that it moves forward because we think it's a good solution. Not everyone agrees with us, so. Hard to say. We thought it might move forward in the last meeting, but it didn't. So there's more to discuss and more to figure out there.
So what practical things, either of you could answer this, would Realms unlock that I couldn't do today? Why are you excited for us?
Well, I'm excited by the idea that we could have better permissioning for different packages and modules within an app. So like right now, whenever you install something from npm, you include it in your Node.js app, and it can do anything that your code can do. Mm-hmm. There's no way to sort of say like, this module is just it's a pure function. It's just computing something based on its inputs, giving me an output. It shouldn't really need the ability to talk to the network or to read files off my file system. I want to be able to just run this module in like a purely isolated environment where I can restrict it from doing anything I don't want it to do. And I think, Realms would enable that. I mean, obviously you need to build some tooling on top of it to make it actually easy for people to use it, because I think the API, when I last looked at it, was pretty low level. Yep. But yeah, that's a really cool idea. And I could see that paving the way for a world where you have almost like smartphone style permissions. When when you install an app for the first time on your phone, it says, hey, I would like to use the camera, or hey, I would like to use the microphone. When I install a package from npm, it would be cool if I had to opt into the permissions that it wants. And if it tried to change those permissions, if someone published a patch version, and suddenly it's reading files off my disk, and where it wasn't before, I feel like that's the thing where you want it to really be a red flag. Either it should fail, or it should effectively prompt the user for permission in some way. The developer, what I mean when I say prompt, I don't mean literally a pop-up running in your Node app, but something where you have like a configuration file that sort of grants permissions to different packages. There's actually some cool work in this area right now with a project called LavaMote. They're using, I think, probably using the shim that you mentioned, Yulia, because I guess, yeah, you can use it today in Node, but I guess it would be better if it was using real realms. I'm not so sure. I haven't looked too in depth into it, but it's called LavaMote if people are interested in looking at it. Yeah. One thing
that's so. I don't know how much time we have until the next break. 3 minutes. I don't know how quickly I can do this. Okay, so one thing to keep in mind about realms is that, another thing that people can look up is compartments. Realms is the underlying proposal that will allow compartments to exist, which is the thing that will say, this realm can have access to these pieces. And here you go, this realm, and go and do stuff. Realms is a fantastic way to do encapsulation of certain types of logic, in particular to keep the integrity of a program running as you expect. One thing that Realms will not give you, and this is another place where browsers have a very strong opinion, it's security. So a Realm will not be a full sandbox that will protect your code because of Spectre. So anything that can take advantage of Spectre is immediately insecure, and Realms doesn't run in a separate process. So the only way you would be able to get full security is if you have it running in a separate process, just because of this massive vulnerability that came up. But realms are still very useful for this integrity question and encapsulation. For example, if you want to run a test suite on a given, if you want to run a set of tests, you can run your test suite inside of a realm, and you can run the program that you're testing separately. So that's a really interesting application of realms. And of course, there is the compartments proposal, which will allow you to say, okay, this should only have access to fetch, time, and some other things. And then otherwise, it can't automatically access things accidentally. So it just won't have access to the time API, for example. It can still escape the box, but it's a little bit more contained, a little bit more controlled.
Mm-hmm. Right. So it sounds like you shouldn't run outright malicious code inside of a realm and rely on it. Yes. But if you're running something where, I mean, I still think if I were to install a malicious npm package by accident because it got compromised, I would be much happier having it run in a realm than having it run, randomly on my computer, being able to access all of the core Node APIs and reading files and child process.execing things.
Totally.
Is that fair, or am I thinking about it wrong?
Well, the thing is, I don't want you to have the wrong model to think that it'll actually protect you, because the best way to make sure that that is properly sandboxed is by running it in a separate process that doesn't have access to everything. So that's the best guarantee that it won't escape the sandbox. But if, say, you're downloading a npm library and you're like, and you're not really sure if you trust them, how they've used all of the APIs correctly. Not that they're actively malicious, but maybe they made some small mistake. Not everything blows up, for example. For example, they won't polyfill your array object to do the wrong thing suddenly, which would suck. You have your own copy of the array object outside of that realm running in the parent realm, and you can use that instead. But if you have a malicious code running in a realm and it's written in a time when realms exist and it knows how to escape realms, it will be able to escape realms.
An escaping a realm in this case means running code like outside in the outside of the realm, not just like leaking some information.
Mm-hmm.
Oh, okay.
Yeah, it's just that realms are not a strong security boundary. I don't know right now. I'm not very confident in what I'm saying because I haven't looked at realms for a while. But the thing that's sort of like being like, one thing you should keep in mind is it's not a strong security boundary.
Mm-hmm. Okay.
It's more of an integrity boundary, which is another way to think about security, right? Like the definition of security has multiple facets to it, and integrity is an important one, and that's what it gives you.
Cool. I could ask you more and more questions all day about realms, but I will refrain myself. It's a cool proposal.
Yeah, it is a very cool proposal. I'm not an expert on it, actually. The best people to talk about it are the champions. So.
Well, I found the compartment proposal. We'll get the realms proposal and lava moat in the show notes for those who want to do their own research. Let's take a break right here, and we'll be right back.
Cool. You know what realms are? That's awesome.
Oh yeah, I think they're really cool. I mean, I wish they were more of a boundary than that. I didn't realize that they could like literally escape, like, and just.
Yeah.
I mean,
the way you were describing it, Feross, made me think of the way that Dino's doing things with like opt-in on certain.
Well, yeah, Dino's doing it, I think, at the wrong layer. I mean, they're doing it at the process level, which means that in practice, any app that's doing anything interesting is going to need to have all those flags turned on. I mean, like. Think about it. Like, what kind of node app are you running that doesn't need either disk or internet, networking access? Like, basically,
I know.
You almost. I mean, I
wrote a 15-line Dino script that with one task. Well, I mean, I guess it's a couple things. All I wanted to do was hit the Slack API to get our list of. I was just giving away free tickets to a JS event, and I was like, let's just get a random member out of our JS party channel. That was the goal. It's out there on the internet somewhere if people are interested. And it was like, I just want to hit the Slack API and then pick, and then get all the member handles, put them in an array, shuffle it, and pick 3 or something like that. And output the, and I had enabled pretty much everything to do. I had an enabled network. I had enabled cookie. I can't remember that. Allow env. I had allow env because I didn't want to put the actual security token into the file. I just want to have it in my environment and read it. Allow env, allow network, and I don't think I had to allow this guy. Anyways, the point was I felt like I was kind of giving it a lot of things and I did ask Ryan about that on the show. We had him on the changelog here recently, which is why Dino's on my mind. And he seems to think it's a good compromise. But you're saying that it seems like what you're saying hits home with me. That's like you're probably going to end up like allowing lots of stuff at that level, and then like your individual components are going to be operating at that same level, right? Is that what you're saying? I
mean, I'm not saying it has no value. I still think it's yeah, but I'm just saying that like it would be more useful if it could be more granular, because like if I think about any app that I'm actually running in production that I care about, it's going to have all the flags turned on. Like, I mean, I can't really think of an app that wouldn't. I mean, maybe. No, I mean, everything is going to need to read disk. Everything is going to need, like, think of a typical Express server, right? It's going to read files. It's going to read files from your disk. It might even be writing files, but certainly needs to read them. It needs to talk to the network. It needs to access env. It's going to have all those on. And then I mean, then it's, if it depends on what your threat model is. I mean, if you're trying to run like a script that's untrusted and you run it without those flags, then that's pretty cool. But if you're trying to like protect an app and your threat model is that you are worried about malware sneaking into a dependency, then it doesn't help you at all, because it's going to run with it. This is actually the same reason why like OS level permissions are in practice pretty pointless. Like whenever I'm doing anything, I'm using the user account on my computer, and the user account is, sure, it's not root, but like my user account has everything in it that I care about. All my documents, all my like PDF files with like my like social security number in them for jobs and things and tax returns and all that crap is just accessible in my home folder. And so if I'm running, when I run npm install, I'm trusting 1,000 dependencies to all not read those files out of my home folder, because they could. They're running as my user. And so like, it's like, that's why this obsession with like, getting root on a system. Sometimes I feel like it's a red herring, because almost all the juicy stuff is in the user account anyway.
Well, on a user system versus a server. I think on a server you want root, but I understand what you're saying on a laptop or something like that.
But I mean, even on a server, like if you can run as the web process, right? Run as the user that's running the web service, then you can impersonate the web service. You can kill the web service process. You can set up a fake process. You can take user requests and send them anywhere you want. You can basically do anything you want to the web service. You can't like own the whole system, but you can like steal every request that's coming in. You can send malware out in every response. You can,
Yeah. So you're talking about a server that hosts just a single application.
Yeah, exactly.
Yeah,
I mean,
totally.
the world where like people run like a server that has like 20 services on it, or like 100 different people are logging into it, like that's still around, but I guess I just run into that less. I mean, at a university, like for example, they give you like SSH access to the computer cluster.
You and everybody in your school.
Yeah, exactly. And so then it's really important there, obviously. I'm not saying
Right.
that multi-user systems aren't used anywhere, but it's just, I mean, in practice, I have a laptop with one user on it, and that's what most people have.
Yeah, totally.
Yeah.
The discussion around realms is really interesting. I don't know if you can execute arbitrary code outside of the container. I'm not really sure you can do that. I think probably you can't, because that's what you need the membrane interface for. So like, the whole SES shim, it creates this membrane using proxies to allow you to do telepresence across the layer. So I don't think you can, I don't think you will be able to cause stuff to run, but my security knowledge isn't that strong. So I don't know the answer to that, but for sure you'll be leaking sensitive data into the realm. So if you're running malicious code that, for example, wants access to your Bitcoin wallet, and you've got like some a key stored somewhere, and it picks it up and it's like, oh, fantastic, I have all your money now.
Right.
So something like that could happen. But it is, I think that this direction of thinking is the right way to go. And this is why I think WASM ultimately adopted the compartments-based system for their security model, because WebAssembly works from the ground up with compartments, which is an idea that was introduced by Mark Miller in the JavaScript committee for SES, Secure ECMAScript. So it is a really interesting space. And I think in the future, if you wanted to build that kind of app, you would be able to run. So we now have we have V8 running on V8, Node running on V8. You would be able to run, for example, a V8 instance or a SpiderMonkey instance on WebAssembly and have true encapsulation there. Of course, the communication and also the weight of those things is going to be very heavy. That may be improved over time, but those would be completely separate processes. Also, workers, if you can run them on separate threads, on separate processes, would be a full security boundary that prevents Spectre from being a real threat. Or, another thing can happen. Processors are developed further, and we end up with a new security model for computers that doesn't have the Spectre vulnerability, and suddenly realms will become a stronger guarantee.
Huh.
Yeah, so all very interesting topic, the realm stuff.
We could do a show on realms.
I wish I was more of an expert on it. There's just so much information to handle at committee that I just can't follow all the proposals carefully. So I missed details. Like the question that you asked, I was like, shit, I don't know the answer there.
Sorry for putting you on the spot.
No, it's fine. It's a lot of fun, actually.
All right. So that was still the break, although maybe might throw some of that back in as an Easter egg at the end, because there's some good thoughts there, so it may end up trickling some of that back into the show. But let's do the third segment. We've been going a little long, so maybe keep this one a little bit shorter. Shoot for 10 minutes. What's One question I have, which I would love for you to answer, but I'm not. I'm going to pre-ask it because I don't want you to say I can't really do that. Is like how holistically do you understand Firefox, insofar as how it's glued together? Like when you load a web page, could you take us through how Firefox works and how where SpiderMonkey fits into it, or do you focus in more on the engine?
I can answer that partially. I can't answer it fully, but I can give you a partial answer.
I think that'd be a nice thing. I mean, I would like to hear that because I understand like the components, but web browsers are still kind of black boxes to me because I don't ever develop on them. So maybe we'll just start there and just let the conversation go. Anything specific we want to hit? We haven't talked about your new pet feature, but that one's on hold right now. So maybe the defer thing.
Yeah, the deferred module evaluation, which actually has a lot to do with module loading. We can use it as a way to talk about how the browser understands stuff because it fits in there.
You want to start with the browser or start with that and work our way in which direction? Makes the most sense.
I don't know. It can go in either direction. We'll just let it happen. I think the conversation's been going really smoothly, so it'll happen.
Totally. Okay, I'm going to start with my big picture question then.
Okay.
So many of us are just building apps for the browser, using the browser to live our lives. We don't really understand exactly how it works. We know that SpiderMonkey is a part of Firefox. You mentioned Gecko. We understand that V8's inside of Chromium-based things. And SpiderMonkey, you can embed in a bunch of stuff. But let's take Firefox, for example. When I load a web page, let's say I load hag.codes, and Firefox does its thing. Can you explain, at least to some level of granularity, how it all fits together? Like, where is Firefox interacting with your work, for example?
So I won't be able to answer this fully, but I can answer it to the best of my ability and get to the point where I start to understand things well, which is the script loader. So my understanding, my mental model of what the browser is doing is you type your URL into the URL bar and you press enter. And when you press enter, that string is taken and put into our network handling component. I think it's Neko, which is the thing that goes and retrieves the information from the web. It like goes and makes the requests using TCP. And then it's like, go and get me this information. And then it starts getting a stream of information in and packing it together. And then once it's packed together, something that looks like an HTML page. And I think we don't even wait for the entire HTML page to load. We start parsing it earlier and like incrementally building it because HTML is very permissive. So this is how I imagine we're doing it. And you're loading your HTML, and as you're loading the HTML and parsing it, you're building up a representation called the DOM, which is the document object model. And in the DOM, you eventually hit something that's a script tag. Once you hit a script tag, depending on how it's being loaded, it might be loaded as async or deferred. And also the type of script that you're loading. The script loader will be called and do slightly different things. The script loader will get the request and be told, here's the script that you need to go and fetch. It will go and open a channel to fetch the things from the network. So this is going to be your next network request. And the stream will come in and we will pack those bytes until we have a file that we can represent. And once we have the file that we can represent, we then take that, and I don't know the exact switch that happens here, but we usually try to parse things off the main thread. So we delegate it to some other thread, and then it takes care of the parsing, and then it takes care of getting it all ready for it to be run. Once it's ready to be run, we execute the script. And depending on how you've written your HTML page, the document onload will fire before or after the script has been finished parsing, has been finished executing. So depending on if you've got a regular JavaScript script, this is what will happen. So this is the regular flow, as I understand it. Then if you've got a module flow, it's a little bit different. So what happens when you've got a module that you're loading, what'll happen is it'll encounter the script tag, and the script tag will say that it's a module. Or it'll encounter a normal script and find inside of there a dynamic import. And once that happens, that triggers a slightly different process where you'll go and you'll fetch the script and get it and then parse it and be like, okay, now I've got a module. And that module will have a different representation, which is a list of other scripts that I want to load. And immediately your browser will go and fetch those other scripts, all of them. So the entire module tree will be fetched and parsed ahead of time. Then Once everything is ready, we start evaluating everything. Now, in classic scripts, you'll evaluate from the top down. In modules, you will evaluate from the innermost module back to the root module. And this is maintained even in top level await, where all of the modules are transformed from synchronous code into asynchronous code. So each module is represented as a promise, which we evaluate one after the other. So in one case, you're interacting with a promise machinery. In the other case, you're interacting with regular machinery. And yeah, and then you load the innermost module, then go out like a Matryoshka doll. And then you've got your complete application running, probably in a loop, doing stuff, listening for events, stuff like that.
All right. So that's a very good explanation. I definitely appreciate it. At which point in that does the SpiderMonkey engine engage? Is it merely on, here's a block of execute this code, or is it also in the module loading and the Russian dolling effect?
Right. So there's a really interesting thing about how the spec actually dictates how the engine also interacts with the host that it's in.
Yeah.
These are called host hooks. So exactly what you said, that second point, the engine is engaged. SpiderMonkey gets called at the point where we're ready to parse. So SpiderMonkey takes care of all of the parsing, and it takes care of all of the execution side of things.
Okay.
But for example, with modules, those, like with scripts, you can more closely couple those. You can like parse it and like, do whatever work, and then like you can evaluate it, but you can also do them one after the other immediately. With modules, you can't necessarily do that. You need to first fetch everything and do that as part of the fetch step. Once you've fetched, and in order to fetch everything, you need to parse. So you need to both fetch and parse all of the scripts. And then you can separate evaluation from that. I have a proposal around this because one of the issues around modules is that the number of network requests you need to do to load an entire module tree can impact your app's startup performance pretty significantly. That parsing and fetching chunk can take up about half the execution time of a module. So one of the thoughts was, can we completely decouple these two parts of module loading? So that first part happens entirely, that first part is handled by SpiderMonkey. SpiderMonkey is called by the script loader to go and do this work, the parsing, the fetching, and the linking of all the modules together. And then SpiderMonkey is later called to do the evaluation work. So it's sort of like all of these things sort of like linked together. And what SpiderMonkey does is after it's parsed the modules, it actually calls back into the host, the script loader, and tells the script loader to then go and do the fetch. So these two things are sort of like hooking into each other in this way.
Now I know why my website's so slow. There's so much to do. I mean, the amount of complexity and depth to this is somewhat overwhelming in the sense of when you really think about it. And we take it for granted because, I mean, I joke about my websites being slow, but it happens all so fast, It's crazy.
Yeah. Yeah. And in some cases, like, we might be able to improve module load performance without doing deferred module evaluation. Like, there is a gulf between the CommonJS module era and where we are today, in that a number of CommonJS modules cannot be directly translated into the ESMs. And that's one of the problems that I want to solve at some point, because we have a similar problem. We have an early adopted module system that doesn't actually work for the web. You might ask, why doesn't it work for the web? So I mentioned that loading modules while running scripts is something we can't do. The reason we can't do this is if we run asynchronous code during synchronous code, we have to block the main thread. That's something we never want to do on the web, because then things lock up. That's a bad user experience. So that's why we want all of our APIs to be async. It should all be delegated to go and be done at a later point in time. So we can't do what CommonJS, the original CommonJS implementation did, which is block until the request finishes and comes back and then continue executing. So that's a unique problem where if you want to transition from CommonJS into ESMs, you end up rewriting a lot of your code as async. And that can be hard to look at and hard to reason about.
Mm-hmm.
thought you were gonna say something, Feross. You looked around like you're ready, like you're cute, like you're teeing one up.
I considered it, and then I bit my tongue.
Okay. Well, you feel free to loosen. Otherwise, I can drill down on.
Yeah, I'm
one.
super interested.
No, I'm good.
Okay.
Okay.
So talk about this. Tell us more about this proposal you have, and maybe its process. This might tie together both subjects now, because we have your own personal proposal. This ties into the SpiderMonkey's work and Firefox's needs, and it's kind of a stage 1, or maybe it's on ice. What's the status? And maybe like tell us the story about it. This deferred module loading thing or execution.
So deferred module evaluation will give developers the ability to say that they don't want the module to execute until it's needed. So, for example, on first use, let's say you've got a module graph that you want to load, and it all gets fetched and it's ready for you. But you can select certain modules and say, I don't want them to run yet. I want them only to run if I actually use them. For example, if someone clicks a button on your React page, someone clicks that button and you want to load in another component, and you don't want to load all of that, run all of that code ahead of time. You want to run it later. And there are other optimizations for this. This is sort of a simple example of this. One way to do that is, I think React now has a way to hide the asynchronous nature of this fetch, so that it looks like it's synchronous code, but it isn't actually synchronous code. And I think they use error catching in order to do that. It's a really interesting approach that they took, algebraic effects. But it also shows that this is a problem, and developers are having a hard time reasoning about this asynchronous code, which is a complexity of the web platform that isn't their fault and isn't actually logic in their program. It's logic about the web. And the question is, how do we remove that complexity so that it's easier to program for the web without having to do asynchronous code when you don't intend to do asynchronous work? And deferred module evaluation is one stab at it. There is another way to do this, which is by exposing the module loader itself and allowing programmers to write their own module loaders with their own logic around module loading. So you could, for example, re-implement a common JS loader that has the same concepts as CommonJS, but it takes into account the asynchronous nature of the web, and allow people to program as they would, and then handle that stuff within the loader. So that's one way we could do that, by exposing the loader. And then deferred module evaluation does that automatically for you. It's an opinionated approach to it. Not everybody would be necessarily happy with that. Not everybody already is happy with that. So we might take a slightly different approach. It is a little bit on ice right now because I am working on revamping the module loading in Firefox, so we can do it for workers as well. So until I figure that out, because it also impacts our internal project, which is reworking our internal module loader so that it can do the same stuff, it might in turn influence that proposal. And then we could bring this research into the open web and allow people to use it as well.
Huh. Well, I can't give any opinions on your solution, but I can tell you that your problem is on point. Like, your problem statement is 100% valid with this guy. And I would definitely appreciate ways of, I guess, papering over. Maybe that's a pejorative. I don't mean it in a negative light, but like solving that problem of this impedance mismatch between async and sync, and the mindset of the developer causes lots of slowdowns in development cycles and bugs. And there's lots of education that has to happen because of it, where if we could solve that problem in an elegant way, that would be a huge boon to all of us.
Yeah, I think this is where we come to the sort of like third phase of development. We haven't talked very much about the formal aspects of, sorry, not development, language design. We've talked quite a bit about decision-making as a group, as an aspect of language design. And now we're talking a little bit about the mental model, how a program's language design, how a language's design will impact how people model problems. And one of the parts of that is how much do you expose of the complexities of the domain in which you're working to the programmer so that they can work with it directly, and how much of it do you hide so that they can work more efficiently with the domain that they're interested in representing through code. And I think that's a really important problem. And in some cases, we want to give lower level tools. In other cases, we want to give higher level tools. And in some ways, this aspect of the web, the asynchronicity of the web by requirement, if we can do that by design, would be really interesting, I think, for developers and make it easier for them to work with their chosen domain, the one that they're trying to implement. Yeah.
Fascinating stuff, Yulia. Hey, you are welcome back on JS Party anytime. I've learned a lot today. You're very bright. You're very good at explaining things to people with lower capacities like myself. Honestly, please come back. Maybe we'll have you back to talk a full episode on Realms. Maybe bring somebody from the committee who's a champion, a Realms champ.
We should get a Realms champ on here.
Yeah, we should. We'll bring our Realms champ. It's Feross. He'll be on our side. You bring your champion, we'll bring ours. And we can have a proper Realms conversation with a little less hand waving than the three of us had to do. That would be really fun. But best of luck to you on your masters and all you're doing. I hope you get your live stream back up, and appreciate all the work that you and everybody at Mozilla does on SpiderMonkey and on Firefox. This is important work, and you're pushing the web forward, and you're doing it in like this group, like thinking of everybody, best idea wins way, which ultimately means we all win. So we appreciate your efforts on that front as well. Feross, thanks for being here. Thanks for hanging with us.
Mm-hmm.
That's our show for this week.
Thanks a lot, Yulia.
Thank you both for having me here. I had a lot of fun. I hope we can do it sometime again. That was great.
We absolutely can. All right, that's our show, and we'll talk to everybody next week. Okay. We're now in post-show. You can threw a lot of hard balls at you. Well, maybe they weren't that hard, but for us,
I think
balls.
I think I got the document loading thing wrong. I've never actually worked on that, so I have no idea.
Oh, well, thankfully your audience won't call you on it, or at least I won't.
They might.
I don't know.
It's okay.
Yeah,
it's okay if they do. Then I get to learn something. Whenever somebody calls me on something, then I learn something.
Oh, totally.
It's good.
Totally.
I gotta jump off. I got something I gotta get to. But it was
all right.
Nice meeting you, Yulia. I just followed you on Twitter. I'll try to check out your
cool.
tweets.
I'll follow you back. I tweet nonsense.
Oh, really? Anyway, but yeah, it was nice to meet you, and I'll see you next time, Jerod. I'll catch you around. Bye.
Yep. See you, Feross.
Bye bye.
And
that was awesome.